Alright, this is systems of linear equations. This is the graphing method. So what we're going to do is try and graph these and find the solution. So let's just graph them first. So we have 2x minus 3y equals 9. And we can try to do intercepts if you want, but I'm going to solve it for y. So we always subtract the x and then divide by whatever's in front of the y. And there we go. So that means we have a slope of 2/3 and a y-intercept of 0, -3. So 0, -3, and then it's up to over 3. And with these you want to be very precise. So up to over 3, just keep drawing the slope, and even down to over 3. Just keep following that path. And there it is. Alright, let's try to get this line on here. And there is our line. So now we got to graph the other one, and that's x equals 3. So we go to x equals 3, and we're going to draw a vertical line. And there we go. That's our x equals 3 line. And as you can see, they intersect right here. And that point is 1, 2, 3, comma, -1. And what that means is that's a solution that they both contain. Remember, every single point on the line is a solution to the equation. So, if they both contain that point, then that's a solution for both. And the way you can tell is just by checking it. So if we take that point, 3, comma, -1, plug it into both, it should be true. If not, there it is. Checks out. Plug it in the other one. Checks out. So that is 100% our answer. 3, comma, -1 is our solution. Alright, let's take a look at another one. So we have 3x plus 1. They're already ready for us. So we put a 1. And our slope is 3. We go up 3 over 1. Up 3 over 1. And then I'll put a line on there. Alright, and that's our y equals, what happened there? That's our y equals 3x plus 1. So now you have to graph the other one. Let me do that in blue. So we're at -2, and then up 3 over 1, up 3 over 1, and then you put a graph for that one. And there you go. And if you notice, they don't intersect, which means they do not have a solution because they will never cross, so they'll never contain a point together. So for this one, we write no solution. That's it. It's because they're parallel. So if you ever see that they're parallel, it's no solution. Alright, next one. So we have y equals 2x minus 4. You can already see they're exactly the same line. So when you graph them, there's -4, up 2 over 1. They're going to both be exactly the same line, which means they have an infinite number of points of intersection everywhere on there. So the answer is infinitely many solutions. In fact, any solution for this one is going to be a solution for that one. They're not going to look this way, but when you graph them, they will look exactly the same. And that's your 3 types that you have. You have one solution where they actually intersect, no solution because they will not intersect, or an infinitely many number of solutions because they overlap. They're exactly the same line. And so when we do later stuff, this will make sense, but when you see this right here, then you get a point. When you have no solution and they're parallel like this, you're going to get a false statement. And when you get something like this, you'll get a true statement. So just remember that. This is our answer. And when it occurs, it's false statement. And when that occurs, it's a true statement. All right, and that's graphing systems of linear equations.